back. Today we're starting one of the most important units in all of Mathematics 7, the equations unit. And we're going to start that unit with one-step equations. So let's go ahead and get started with that right now. Now, when solving an equation, we have a few key ideas. When we're solving an equation, we use inverse operations to isolate the variable. So we're going to be doing different operations because we want to get the variable all by itself. So to eliminate a constant term, we're going to use addition or subtraction. To eliminate a coefficient, we're going to either use multiplication or division. When solving an equation, we must do the same thing to both sides of the equation to keep it balanced. So whenever we do something to one side of the equation, we need to do it to the other side of the equation to that way that our equations stay balanced. So let's take a look at that with some visual representations. So what we have here are a couple of pieces that we can be using to visually represent how to solve an equation. They're very helpful for some people not so much, but it's a good idea to know what they are so that when you see them, you know what they mean. So anytime I see that long bar with a plus sign in it, that means X. Just one X by itself just means X. Anytime I see a small little square by itself, I know that means positive 1. Anytime I see a long bar with either a minus sign in it or that it's red, I know that's going to be negative X. And anytime that I see a negative small little circle with or a small little square with a negative sign in it, I know that's going to be negative 1. So now I've got a couple of questions. It says, how do you build the expression x minus 2? So I want to show an expression, not an equation. You know it's an expression because it doesn't have an equal sign. So how do I show x minus 2? I'm going to start by drawing my x, and I know that's going to be just one bar. Then I need minus 2, so I need 2 of those little squares. One for minus 1, one for minus 2. So I've got x minus 2, 1x minus 2. My next problem says, how do I build the expression for x? So I want to have 4 of those x's. So to do that, I'm going to just have those long bars. So I'm going to have 4 of them, so that I have 4x. So now that I have a better indicator of what these things look like and what they mean, I'm now going to use them to try and solve some equations. So let's go take a look at example A. Here we are at example A, and it says x plus 2 is equal to 5. And notice I've drawn a line right down from my equal sign because I know that I have to keep my equations separated. Okay? It's an equation as a balancing act. I have to keep whatever's on the left side, and whatever's on the right side on the right side. Whatever I do to one side, I have to do to the other. So that line reminds me that I have a wall there that I have to work over. So now let's start by drawing our equation out with our visual representation. So I have x plus 2 on one side, so I'm going to take my long bar for x. Then I've got plus 2, so I'm going to do plus 2 on that side, so I've got x plus 2. And on the other side, I have positive 5, so I'm going to draw out my positive 5. Right there, now I've got 5 of those. So now I have to solve my equation, because remember, I want to get x by itself. So in order to get x by itself, I have to get rid of that plus 2. I have to take it away from that x. So to take it away, the opposite of the plus 2 is to subtract 2. So I'm going to take 2 away from that side, and that will leave me with just x, so that works. However, I can't just take x from one side, because remember, what I ever do from one side, I have to do the other so that my equation remains balanced. So since I took 2 from the left side, I have to take 2 from the right side, and if I do that, I'm going to take my 2 away, and then I'm going to be just left with 3 on one side. So now I have x is equal to 3. So x is equal to 3. So that is the answer to my equation. X is equal to 3. And if I were to test this, I could figure that out to find out that is correct. If I plug my x back into my equation here, if I were to take my 3, plug it in for x plus 2, and see if it was equal to 5, 3 plus 2 does equal 5, so 5 equals 5, so yep, I got that correct. So using my visual representation, I was able to see what to do and then check it to see if I got my answer correct. Let's take a look at example B. So in example B, I've got negative 3 is equal to x plus 1. And notice again, I've got that wall down from the equal sign separating that negative 3 and that x plus 1. So I'm going to start with my visual representation. I'm going to draw out my blocks. So one side I've got negative 3, so I'm going to have negative 3 counters over there. Then I've got an x, so I know that's my big long bar. And then I've got plus 1. So now I've got to get x by itself. In order to do that, I've got a plus 1 there. So I have to take 1 away. That's the only way I can take 1 away. However, if I'm looking at my equation, I don't have the same things. In the last equation, I had positive blocks on both sides, so I could take 1 away from each. In this case, I've got red blocks on one side and blue blocks on the other, so that won't work. They're not the same thing. I can't just take them away. So I'm going to have to cancel them out. I have to cancel out my plus 1. And the best way to cancel out my plus 1 is with minus 1. So if I bring in a minus 1, my plus 1 and my minus 1 are going to cancel each other out so that I don't have them anymore. And then I'm going to have to do the same thing to the other side. I'm going to have to bring in a negative 1 block. Since I brought a negative 1 block to the right side, I have to bring a negative 1 block to the other side. And now I have negative 4 over there. So my final answer to my equation is negative 4 is equal to x. And again, I can check that to see if I'm right. So I'm going to take my negative 4 and plug it into my original equation. So I had negative 3 is equal to negative 4 plugged in for x plus 1. And I can use my calculator if I don't know my integer rules, but I know that negative 4 plus 1 is going to give me negative 3, and that is equal to negative 3, so I know that I did this equation correctly, and I can check it. Now let's take a look at example C. So here we are in example C, and it says minus 2 plus x equals 6. So again, I've got my line down for my equal sign, and I'm going to have to build my equation. So I've got negative 2 there, so I'm going to have negative 2 blocks there. I got a positive 1x, so I'm going to have an x blocks there. And then I've got positive 6 on the other side, so I'm going to have 6 blocks on that side. So now I've got to figure out how to get my x by itself. And since I'm trying to get my x by itself, I've got to get rid of that negative 2. So I've got to figure out what is the opposite of negative 2. What is the thing that I could do to get rid of that? And the opposite of negative 2, because there are different blocks on each side. I've got red blocks on the left, I've got green blocks on the right, so I know they can't cancel each other out, or I can't just take away from both, so I am going to have to cancel out. And in this case, I have negative 2, so the opposite of negative 2, I'm going to have to add 2 to this side in order to get rid of that negative 2, because negative 2 and positive 2 will cancel each other out, and I won't have to worry about them anymore, and I will have just my x. But since I added 2 to that side, I have to add 2 to my right side. So if I do that, I'm going to end up with 8 on the other side. So my final answer to this equation is x is equal to 8. And again, we can check it to see if we're right by using our original equation. So we can take our negative 2 plus the number that we just found, which we said was 8, and we see that it will answer 6. Negative 2 plus 8, again, if I don't know my integer rules, I hadn't used my calculator, but negative 2 plus 8 is going to give me 6. So does 6 equal 6? Yes, it does. So I know I solved my equation correctly. Now let's take a look at how to do this without using our visual representation. Now here we are, we have 3 different problems and we don't have our visual representations, but that's okay because we're not going to be walking around forever in math carrying around these blocks in our pockets or drawing these blocks on our paper. We want to be able to solve equations without having to do drawing of blocks. So to do that, we're going to need to be able to solve our equation using inverse operations. So I'm going to again start on my left hand side by drawing a wall down from my equal sign. That's very important to me so I can make sure that I'm keeping my equation separated. X plus 7 is different than the 9. So now I need to perform the inverse operation. The inverse operation of plus 7 is minus 7. And that will cancel each of those out. Positive 7 minus 7 will give me 0. However, I can't just do something to one side of the equation. I need to do it to both sides of the equation. So I'm going to put a negative 7 on both sides of my equation. I'm going to draw a line there to know that I'm separating my steps. Now granted, these are one-step equations, so there is only one step. However, later on there will probably be more steps, and it will be important to make sure that I keep them separated. So again, the positive 7 and the negative 7 cancel each other out, leaving me with just x on this side, and then 9 minus 7 is 2. And again, I can check that. Does 2 plus 7 equal 9? Yeah, it does. So I know that I got that equation correct. Let's take a look at the one in the middle. Again, I'm going to draw my wall down from my equal sign, and I've got x plus 4. I want to get the x by itself. doesn't matter which side the x is on in any of these equations. I'm always trying to get the x by itself, or the variable by itself. It may not always be x. So I got to get x by itself here, and I've got plus 4. So again, I'm going to perform the inverse operation. So the inverse operation of plus 4 is minus 4. So I'm going to subtract 4 from one side, but because it's an equation, I have to subtract 4 from the other side as well to keep my equation balanced. Positive 4 and negative 4 are going to cancel each other out, leaving me with just x on one side. And then negative 2 minus 4, if I don't know my integer rules, I can use my calculator, but that will give me negative 6. Now let's go to our last problem there. Again, I'm going to draw my wall down from my equal sign. I'm going to get my x by itself, but I've got a negative 5. So I need to determine the inverse operation of negative 5 or the inverse operation of minus 5. That minus symbol means the same thing, negative or subtraction, same thing. So the opposite of minus 5 is plus 5. But again, because it's an equation, I need to do that to both sides. So negative 5 and positive 5 are going to cancel each other out, what leaves me with just x on this side, and 8 plus 5 is 13. So again, I can check that. Does 13 plus negative 5 give me 8? Yes, it does. So I know I've done this problem correctly. And it's always a good idea to circle your answers so they can easily be found on your paper, whether you're doing a test and a quiz or a classwork assignment. Let's move on to the next one. So here we are in example E, and it says using our visual representations again, I have 3x equals negative 6. So if I see the 3 next to the x with no other operation nearby, I know that that is indicating to me that we are doing multiplication. So we're going to start with our visual representation. I have 3 x's, so I'm going to draw my 3 x's on each side, or on the left-hand side. And then I've got negative 6 on the other side, so I'm going to bring in my negative 6 to that side. So now I need to remember what my inverse operation is. And my inverse operation of multiplication is division. So I have to divide both sides by 3, or I have to divide that group of negative 6 I have into 3 different groups. So I'm going to take my 3 and I'm going to take my negative 6 and I'm going to divide them so that I have an equal amount in each group of the x's. So for the bottom one, I'm going to give that 2. For the middle one, I'm going to give that negative 2. And for the top one, I'm going to give them negative 2. So you can see that I've divided them into equal groups. Here's a group, x equals that one. Here's a group, x equals that one. Here's a group, x equals that one. So I can see that 1x is equal to negative 2. And I could check that to see that that's right. 3 times negative 2 is negative 6. So I know I've done it correctly. So when I'm using visual representation to solve multiplication, I just need to divide and break out my x's into the different groups. Now let's try solving it without a visual representation. So here we are at example F, and I've got 2 different problems to solve without a visual representation. I have 3n is equal to negative 12, and negative 5n is equal to negative 15. So I'm going to start by drawing my wall on my left-hand problem. Now I need to remember what is my inverse operation. Since I see 3 next to the n, I know that's multiplication. So I need to do the opposite of multiplication, which is division. So I'm going to divide both sides by 3 because I need to do whatever I do to the left-hand side, I need to do the right-hand side, I need to do things to both sides of the equation. Now, 3n divided by 3, or 3 divided by 3, is going to give me 1, or 1n. I don't have to write the 1, I can just write n. I don't need to write the 1. I know that it's 1n. Negative 12 divided by 3 is going to give me negative 4. And again, I can check that. Does 3 times negative 4 equal negative 12? Yes, it does, so I know I've done that problem correctly. Now let's do the one on the right-hand side. Again, I'm going to draw my wall down from my equal sign, and I've got negative 5 times n. So I need to do the opposite operation. The opposite of times negative 5 is to divide both sides by negative 5, because again, whatever I do to one side of the equation, I need to do to the other side of the equation. Negative 5 divided by negative 5 is going to give me 1, or 1n. I don't have to write down the 1. I know that just an n by itself is 1. And negative 15 times divided by negative 5 is going to give me positive 3. And again, I can check that. Negative 5 times 3, does that equal negative 15? Yes, it does. So I know I've done my equation correctly. Now let's take a look at example G. Here we are in example G, and it says solve using the inverse operations. So this time I've got two problems, and I can see that I've got y divided by 8 on one side, x divided by negative 6 on the other side. So I'm going to be using my inverse operations, but before I do anything, I want to draw that wall down from my equal sign. So now I need to figure out what the inverse operation is. So here I've got y over a line under 8. So I know that that means division. So I'm going to have to figure out what the opposite operation is for y divided by 8. So the opposite operation of division is multiplication. So I'm going to have to multiply both sides by 8. Now, we could show how this cancels out because we'll be multiplying by 8 over 1 is the same thing as 1 over 8. And again, that's all going to reduce down to 1. 8 goes into 8 one time, 8 goes into 8 one time, 1 times 1 is 1, 1 times 1 is 1, and that leaves me with just 1y. You don't have to do all of that canceling out. You could know that 8 times 8 is just going to give you 1y. You don't need to do all of the canceling I just did every time, as long as you understand that it's going to give you 1y. Now I need to do that to the other side. I need to multiply that side by 8 because remember, whatever I do to one side of the equation, I'm going to be doing to the other. 8 times negative 9, if I don't know my integer rules, I can use my calculator, and I should get negative 72. And I can check that. Is negative 72 divided by 8 negative 9? Yes, it is, so I know I've done it correctly. Moving on to the next problem, I need to divide or draw a wall down from my equal sign. I've got x over 6. I've got that negative sign on the outside, and then that equals negative 4. So I need to do the inverse operation, and the inverse operation of division is multiplication. So I'm going to be multiplying both sides by 6, but wait, that's not going to get the x alone. I need to get rid of that negative sign too, because I'm not trying to find negative x, I'm trying to find just x. So I have to get rid of that negative sign too by attaching it to this negative 6. Okay, now I need to do that to the other side. I need to multiply both sides by negative 6 in order to get rid of both things, both the 6 and the negative, because I don't want either one left. That leaves me with just x on one side as these all cancel out. Negative 4 times negative 6 is positive 24. And you can check this. Is 24 divided by 6 4? Yes. And then I would have the negative sign right there, so that would be negative 4. So I know that I've done it correctly. Let's go ahead and take a look at the last example. Here we are at the last example, and I've got two different problems to do. Now, it says x plus 3.4 equals negative 7.2. This isn't any different than the problem I've done before with the addition and subtraction. It's just that this time I have decimals, but that shouldn't cause me to panic. Decimals doesn't change the way that I do the problem just because they're decimals. All it indicates to me is that I have to pay a little more attention and that I probably need to use my calculator to figure out this problem, but it doesn't change how I do things. So I'm going to draw a wall down from my equal sign. Then I need to figure out what my inverse operation is. Since I have plus 3.4, I know the opposite of that is minus 3.4. So I need to subtract 3.4 on both sides of my equation. These are going to cancel, bring down my x, and then negative 7.2 minus 3.4 I might want to use my calculator for because that will help me. Now, it's not minus negative 3.4. It's just minus 3.4. You just need to type it in as you see it. Don't try and add extra signs. So in this case, I've got negative 7.2 minus 3.4, and when I do that, I end up getting 10.6 negative, or negative 10.6. And I can check that. Does negative 10.6 plus 3.4 equal negative 7.2? Yes, it does. And if you're not sure, you can use your calculator to check. Now I'm going to go to the right-hand side. I'm going to draw my wall down from my equal sign. I've got 2.1x. So I have no other sign in between, so I know that means multiplication. So I need to be doing the inverse operation of multiplication, which is division. So I'm going to divide both sides by 2.1. 2.1 divided by 2.1 is 1, or 1x. I don't have to write out the 1 in front of the x. I can just put x. Then I'm going to do 10.92 divided by 2.1 in my calculator. And when I do that, I should get 5.2. And again, I can check that. Is 5.2 times 2.1 10.92? Yes, it is. So I know that I've done my equation correctly. So anytime that I'm doing this, I can figure out whether I did the answer correctly or not by putting it back in my calculator and determining it. Did it give me the answer that I was looking for? Now let's move on to a couple practice problems. So here we are at practice number 1. I want you to try these 2 problems on your own. Remember to draw your wall down from your equal sign. Remember your inverse operations, and when you finish, go ahead and check your answer. So go ahead and do the problems that you can on your own now. Press pause and then press play again to see if you are right. How did you do? Were you able to get the same answers that I got? If you did, great. If not, go back and take a look at my work and see where you may have made your mistake and correct yours. That brings us to the end of this video. So if you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.